The common cuboid. Yeah, so a cube and a cuboid are not the same thing. What you want to remember is a cube is obviously like a 3D square. A cuboid is just a 3D rectangle. You have what we call a cuber. A cube looks like this. Everything, yeah, bottom brass yourself, bro. Bottom brass yourself. Better be careful. Just draw this cube here. Try and make sure that everything is, is lacquered there. This cube. Yeah. So what makes this a cube is obviously if all the sides are equal. The height, the length, and the breadth. And then they just have to go toop, toop. You see, this is what makes this a cube. But then you have what you refer to as a cuboid. A cuboid is a 3D rectangle, which is this thing here. This thing here is a cuboid. But you're in matric, so you probably knew that. If you didn't, trust me, it's not a crime. It's not a crime at all. It's not even important. So with these two, with the catch your breath. Thank you. With something like this, right? You wanna think to yourself, if you had a cube or a cuboid to work with, right? You just wanna recognize that we have things like surface area. You have an area for like one side, and you also have things like the volume of the entire thing, which is all things that we basically need to cover within this tutorial. So in this tutorial as well, I think we can basically make use of this kind of a shape here to showcase that this kind of a shape here, if you had these kinds of dimensions, could easily go for like a cuboid like this one here. But then let's just state what we need to state first before we get carried away. So when we work with a cube or a cuboid or a four-sided shape, whether it's a cuboid or not, it doesn't matter. What you want to recognize is that when you're looking at the top part here, the area of this top part is just length times breadth. You see? Length times breadth. Now, obviously, when you're done thinking of a 3D shape, it's just the area of this shape multiplied by the height going downwards. You see? So when you're thinking of volume, it's for a 3D shape. You see? Area is for a 2D shape. Volume is for a 3D shape. So when you're thinking of this cube, your volume is just the area of your shape multiplied by the height going downwards. So here your volume is just length times breadth times height, of which if it's a cube, then it's just x cubed. If it's not a cube, if it's a cuboid like this one, then volume is equal to length times the breadth times the value for x. Let's just put dots there actually. So I think volume, there's really nothing much to say, to be honest. Like, I think we're just wasting our time. Let's just refer to surface area. So we already mentioned that when you're thinking of things like surface area is just the area of your different sides combined. Like, that's why this thing here, this is just, a cuboid opened up. So you working out the surface area of a cuboid, it is literally you working out the surface. It is literally you. Hey, catch your breath, bro. Come on. Yes, like it is literally you working out the area of each side and then just adding them up together. So if you had to work out the surface area of this cuboid over here, you would work out obviously the left and the right, the top and the bottom, and then the front and other back. So obviously, if you look at this thing here, I mean, it's just a net, but I mean, you could think of this as like the bottom, and then this is going to be the top. And then obviously this is like the left, this could be the right, and then here this could be the front and the back, like that, you see. So with all this being said here, what wanna recognize is that when it comes to surface area of a cuboid, right, or a cube, don't overcomplicate it. You can literally just think to yourself, okay, if you're going to get the surface area of a cuboid, it's just the different areas of all the different sides added up, you see. Like here, front and back is exactly the same thing. So front and back would be like length here times the height, you see, length times the height, LH. Here it's also just going to be length times the height, LH. If you look at the bottom, it's just breadth times the length. And then the top also is just the breadth times the length. And then obviously the left and the right, your area there is just the breadth here. See, the breadth times the height. There you go. So if you had to get the surface area of a cuboid, it's just a matter of adding up the areas of all these shapes here. So you have these two twice, you have these two twice, and you have those two twice, you see, because I mean the top and the bottom, two of the same thing. Left and right, two of the same thing. Front and back, two of the same thing there. So your surface area here is just 2 of the length and the height there, plus 2 of the breadth and the length, plus 2 of the breadth and the height. You see, it's just like each of them gets a 10 to be with the other one. So length here, you can see length is with breadth and with height. Here base, or rather breadth, is with height and with length as well. And then height, you can see height is with breadth and the length there. You see, it's nothing crazy, nothing major, nothing to even, you know, overly emphasize or whatever. So that's what you always want to think of when you think of cases like these. You see, these are all just cubes, or cuboids rather. Here this would be a cuboid, cube, cuboid. There's nothing much to say about a cube and a cuboid or whatever. A rectangular prism, you see, it's just called a rectangular prism. This here, it's called a cuboid, yes, but it's also called a rectangular prism. Let's just use the normal word that everybody will know. This, they're both just rectangular prisms. Rectangular, it's a rectangular prism. It's also just called a cuboid. But anywho, let's move on to the next shape, because why not?